These are the 8.2 notes for Algebra 2. We're going to be talking about probability today. So the first thing we want to do is just refresh how to work with fractions, decimals, and percents. So the first example, we're just going to take the fraction 12 over 38. And I want to first start by just typing in that into our calculator and getting a decimal out of it. So as you pull up your calculator, we'll type in 12 divided by 38. Fractions are the same as dividing, so you can use that division bar. And then I get this on my calculator. I'm going to write out that whole decimal, 0.31578947737. And so just for this very first one, I want us to write out that whole decimal. All right, and then we're going to do each of what these say. So first thing they want us to do is write it in a fraction in simplest form, which just means you reduce if you can. So take the fraction 12 over 38, and you can reduce that by dividing the top and bottom by 2, getting you 6 over 19. If it asks for a decimal to the nearest tenths place, that means that's going to be 1 decimal point. So we look at the 3, and because the 1 is small, meaning 4 and under, we leave it as 0.3. The next one is asking for a decimal to the nearest hundredth, which means there's 2 decimals. So you're going to keep the 3 1 and allow the 5 to decide whether you round up or not. 5 and up means you would round the 31 to a 0.32. If it asks you for a decimal to the thousandths place, you look at the first 3. 7 is a large number. 5 and higher counts as a large number. And so you'd round up to 0.316. Then for the percent, you're going to have to, for this one, percent to the nearest whole number, you're going to move the decimal over twice. So we're going to take the decimal here and move it over once, twice, and then decide whether 31.5 rounds up. Because of the 5, it does round up, so you would get 32%. If they ask you for percent to the nearest tenth, we would want to keep the 31.5 and just decide about the 7. The 7 is a large number, so it would round up to 31.6%. So each of these problems is going to ask us to round in a different way. Just got to keep an eye on it. Right, example number 1. A spinner is divided into 3 color sections that are not of equal size. You have red, blue, and yellow. The spinner is spun several times, and the results are recorded below. So 13 times the spinner landed on red, 7 times it landed on blue, and 3 times it landed on yellow. If we're talking about probability, we always need a total. So at the beginning of each problem, you're going to want to total those up if that's not given to you. 13 plus 7 plus 3 gives us a total of 23. Based on these results, express the probability that the next spin will land on a red, and then how they want you to express that answer as a percent to the nearest whole number. So how many spins were red? 13. Out of how many total? 23. And then we take our calculator. I'll pull mine up on the screen. And we'll do 13 divided by 23. That's how we're going to get a decimal or a fraction. Sorry, a decimal or a percent. 0.56521. We're going to take the decimal and move it over 2 places. So it turns out to be 56.521. And that would round up to 57% to the nearest whole number. Example 2. 30 students in an Algebra 2 class took a test. There were 8 A's, 13 B's, and 9 C's. If a student from the class is randomly chosen, what's the probability that the student received an A? All right, let's look for our total. Notice they already told you that that was 30 students. So when you add up those three numbers, the A's, the B's, and the C's, you get up to a total of 30. So people did really well on that test. How many people got an A? 8 people got an A. Divided by the 30 total people. Write your answer as a fraction in simplest form. 8 over 30 is a fraction that we can reduce. I know both of these can be divided by 2, giving me 4 over 15. And that's as far down as I can reduce. All right, example number 3. Jessie owns a small t-shirt company. She knows that in the last week, 18 customers paid cash, 25 used a debit card, and 8 customers used a credit card. Based on these results, express the probability that the next customer will pay with a debit or a credit card as a percent to the nearest tenth. So nowhere in this problem did they tell me the total, so I got to figure that out. We had 18 customers pay with cash, 25 with a debit, and 8 with a credit, giving me a total, as I add on to my calculator, 51 people. We want the probability that the next customer will pay with a debit or a credit. So 25 people were using a debit and 8 using a credit. So when I add those two together, I get 33. 33 people out of 51. We'll write our answer as a percent to the nearest tenth. Let's do that in our calculator. 33 divided by 51. Let's write this out. 0.64705. That's enough decimals. Let's move our decimal place over twice for a percent. 1, 2. And the nearest tenth means we want to keep the 7 and decide whether the 0 allows the 7 to stay or bumps the 7, rounds the 7 up. It's going to allow the 7 to stay, getting us 64.7%. Right. Example number 4. This problem is all about high school students choosing their favorite candy bar from a list of 5 different options. So you had 100 students choose Snickers, 82 choose Reese's, etc. I don't see anywhere where they give me the total. So I'm going to add those up in my calculator. 108 plus 82 plus 53 plus 38 plus 12. And a lot of times when I have those larger numbers and a longer list, I'll do it in my calculator twice just to make sure. So I'll type that in one more time. If I get the same answer twice, I know I'm probably correct. I got a total of 293 students. Based on these results, express the probability that the next student surveyed will choose something other than Butterfinger. So anything other than Butterfinger. So you could add up all the other students, or can you think of a faster way to do that? Yeah, 293 minus 38. We'll get you the answer a little bit faster. 255 people didn't choose Butterfinger out of the 293. We'll do that as a decimal to the nearest hundredth. $255 divided by 293. Hundredths means you keep 2 decimal places, and since the third one is a 0, we would keep it at 0.87. Right, example number 5. Below is the grade level and elective class of everyone in the Tigers team at Chapel Hill 7th and 8th grade center. So you've got your 7th graders on the left and your 8th graders on the right. Again, noticing I don't have a total. So that's the first thing I'm going to work on, is getting a total for each of these. So into your calculator, carefully add these up. I got 64 for the total 7th graders. Then I'll add the 8th graders separately. 72. And based on the problem, we might have to add them all together, but I'm not sure yet, so I'm just going to keep those two totals here. All right, so based on these results, express the probability that a 7th grader chosen at random. So our first problem is just focused on the 7th graders. 7th grader will be in choir. So I look to my 7th graders, I look to choir, 24. Out of my total 7th graders, 64. And I just need to write that as a fraction in simplest form, which means I can reduce. When I look at 24 and 64, I know it divides by 2. I also know 4 can go into it. And if you think about it, 8 goes also into it. So you can do it as divided by 8, or you can take as many steps as you need to. Just keep dividing by 2. I'm going to divide by 8 since I remembered that both of those are divisible by 8, getting me 3/8. For the next part of the problem, it's asking about the probability of the student chosen at random. So a student chosen at random, they didn't tell us whether it was 7th and 8th graders, so we're adding all these up, and we need a big total. So add the 64 and the 72 to get a total students of 136. And then we want whoever is in art or theater. So I'm going to add up all the arts and all the theaters. 15 plus 3 plus 7 plus 18. Add those all up. Gets me 43 out of 136. And how do they want the answer? As a percent to the nearest whole number. Percent means we need to divide first using our calculator. 43 divided by 136. Percent is when we move the decimal place over twice. So if you have 0.31617, you move it over once, twice, and they want it to the nearest whole number. So we want to keep the 31 and maybe bump it up because of the 6. The 6 is what's going to tell us whether to keep it 31 or round up to 32. 6 is a large number. It's 5 or higher. So this would become 32%. Okay, example number 6. A jar contains 8 red marbles, 7 purple marbles, and 3 green marbles. What is the exact probability that you pick a purple, then a red? When you see the phrase exact probability, that means they want it as a fraction. So what are your chances of picking a purple? Let's figure out how many total we have. I have 8 marbles plus 7 marbles plus 5 marbles, giving me a total of 20 marbles. And I'm going to pick a purple first. So how many purples are there? 7 out of the 20. But here's the thing. Once you pick a purple, one of the purples is gone and one of the marbles is gone. So now when you go to pick another marble, there's only 19 marbles left. You go to put your hand in there and you pick a red one. There's still 8 red marbles because the first time, remember, you picked a purple. And then we're going to multiply those two things together. So 7 times 8 is 56. 20 times 19 is 380. Both of those are even numbers, so I know I can divide by 2. 28 out of 190, just dividing each of those by 2. I know again I can divide those by 2. 14 over 95. And I think that's as far as I can go. So I'm just going to leave that as 14 over 95. All right, for the next one, what is the probability to the nearest 1,000th place? So that is tenths, hundreds, thousands. That's 3 decimals. That both marbles are green. All right, so when I go back to the beginning, I have 5 green marbles out of 20. But then one of those green marbles is gone. So when I go to pick another green marble, there's only 4 of them left. And there's only 19 marbles because you have a green one in your hand. 5 out of 20 times 4 out of 19 would get you 20 out of 380. And we want it to the nearest 1,000th place, which is a decimal. So we're going to do 20 divided by 380. And 3 decimal places, 0.05. And then the third decimal place is a 2, but the 6 right after it makes it bump up, round up to a 3. Right in the very last problem, what is the probability to the nearest 1/10 of a percent that all 3 marbles are red? So the first marble being red is 8 out of 20. The next marble being red, remember you have a red marble in your hand, so there's only 7 in there, and there's only 19 marbles. And at that point, you've picked 2 marbles, which means now you're down to 6 red marbles and only 18 marbles total. Multiply all the numbers in the numerators, all the way across, multiplying, and all the way across the denominator, multiplying. And then we want a percent to the nearest 1/10. So we'll take 336 divided by 6840. Remember, we're going to move the decimal over twice. So I'll start by writing out the decimal first. And then we move it over once and twice. 1/10 of a percent, you want to keep this and allow the 1 to help you decide whether the 9 stays a 9 or whether it bumps up. 1 is a smaller number, so we'll leave it as a 9, 4.9%.